Lost civilizations, the golden age, Shangri-La. Might there be some truth to these ancient tales? Our ancestors spoke of a grand cycle bringing about high ages of enlightenment and low ages of darkness, marked by the movement of the heavens.
The notion of individuals in their own place of worship being connected to some larger, either terrestrial or cosmic space, is not uncommon.
Mayan astronomy looked at huge cycles of movements of stars. They actually had an exact date in their calendar for the beginning of the world.
The evidence for these advanced civilizations is almost universal in the sense that they seem to be at their height very near the beginning.
Just as day and night are caused by the spinning earth, and the seasons are caused by the earth's orbit around the sun, some ancient cultures believed there's an even larger cycle that influences the rise and fall of civilizations. History and astronomy may help us rediscover this forgotten cycle, a cycle said to be so vast it reaches beyond our solar system, yet affects our everyday lives. Plato called it the Great Year.
There is a season, and a time to every purpose under heaven.
Could it be that our sun is in a binary orbit, creating a 24,000-year cycle that affects the rise and fall of civilization? Many ancient cultures seemed to think so, and now some modern-day scientists agree. If true, there should be evidence of advanced civilizations older than the 5,000 or 6,000 years we find in most of today's textbooks.
Up until recently, archaeology placed the origins of what we would call civilization back about 3,000, 3,500 BC, with the rise of Sumer and Egypt and India, China as well. But over the last 4 or 5 decades, it's becoming clear that there was plenty going on before that.
Recent discoveries of complex structures near Hammacher, Syria, are estimated to date back almost 6,000 years. Still more startling, a team of Indian oceanographers has found the remains of a huge city submerged in the Gulf of Cambay. An astounding 10 square miles in size, the city has been carbon dated at 9,500 years old. And in Nabta Playa, Egypt, a circle of stones acts as a calendar star map that plots the exact points of stars and possibly their distances. Archaeologists believe the site might be as old as 10,000 BC.
Definitely, Indians were in North America at least 14,000 years ago, probably 15,000, 16,000 years ago.
Almost every week or month or so, they're finding some new bit of archaeological evidence that keeps pushing the clock back.
These discoveries confirm that complex societies all over the globe are older than previously thought. There's also evidence that ancient cultures on different continents communicated with each other. Is it just coincidence that the architecture from the Americas, the Middle East, and Asia share some striking similarities? Communication between civilizations on different continents is also suggested by their use of similar timekeeping systems. The Babylonians, Egyptians, and Yucatec Mayans all had comparable means of dividing the days, months, and years.
In Asia and in Mexico, there is a calendar system based on astronomy, which also is used to predict people's fate according to the planets and stars that were above at the moment of their birth. Each day of the month was named after something like rabbit or deer or flint. And there are series of these names that are identical in Asia and in Mexico. Not just the names, but they follow the same series.
If you look at the so-called solar boat of Khufu, this is built unquestionably in 2500 BC, and that's a fabulous boat, 150 feet long with a sail on it. That's as good a ship as anything up to the clipper ships of the 19th century. And so it seems to me that with ships of that sort, pretty much anybody could go anywhere.
While the idea of transoceanic contact is still in debate, there is no question that some ancient cultures were more advanced in some ways than we are today. This is consistent with the cycle of the Great Year.
Much of Egyptology of the last century has been incredibly stubborn and almost deliberately designed to denigrate the achievements of the ancient Egyptian. Part of the blame for this lies, I'm afraid, with Darwin, whose theory of evolution as a linear and inevitable process going from primitive human beings to our own advanced selves, so that it became inadmissible to acknowledge that the ancient Egyptians actually knew more in many ways, certainly than the Greeks. The Greeks, in fact, acknowledged Egypt as the source of their wisdom, and doubly inadmissible to even suppose that the ancient Egyptians knew something that we don't. One of the things that the academics are very good at is denying that a mystery exists when it's quite clear that one exists. For example, the Great Pyramid of Giza, where constructed of 2.5 million blocks of stone, supposedly going up over the course of 30 years, which computes to 1 or 2 blocks are going into place every minute. And when you figure that the roof of the King's Chamber is built of 70-ton blocks of granite, this beggars the imagination. So engineers who look at this say, they laugh, because they say, in no way can you explain how these things got levered up ramps and into place in that period of time, or how they got put into place at all.
Many of the early temples, megaliths, pyramids, and obelisks are not only built to such fine tolerances that they did not require mortar, a feat that modern engineers are hard-pressed to explain, but many of them are aligned with celestial phenomena or reflect sophisticated mathematical concepts, indicating that these ancient cultures had a larger cosmic awareness. According to author Graham Hancock, key temples in the ruins of Angkor in Cambodia are laid out to mimic the pattern of stars in the constellation Draco. Other researchers have demonstrated that the Sphinx of Giza in Egypt aligned with the constellation Leo as it appeared in the sky at that time. These two examples show the connection these cultures had with the heavens, a connection so strong that they integrated it into structures that have stood for thousands of years.
Some of the Maya buildings in Maya cities, like Chichen Itza, whole buildings were constructed solely for the purpose of making astronomical observations. Certain sight lines were built in stone, so that on a certain day of the year, the sun would appear, or a star would appear exactly there on this day alone.
The Great Pyramid itself shows that the shafts of within the King's Chamber, and now subsequently discovered the Queen's Chamber, are sited in such a way that at a certain period of time they open to the position of Sirius in the sky, and in the other case, I believe it is one of the belt stars of Orion. So you might say that the Egyptians are tuning the Great Pyramid to these stars, which play, in fact, a very important role within Egyptian symbolism and in Egyptian mythology.
It wasn't until the early 1990s that archaeologist Robert Bauval found that the 3 great pyramids on the Giza Plateau are a direct reflection of the stars in Orion's belt. This pivotal observation again shows that ancient cultures placed great value on the movement of the heavens. It's not surprising that many ancient artifacts contain celestial images. Rams, fish, and bulls were long mistaken as mere pagan symbols, but we now know they represent constellations and were used to portray astronomical positions. For example, the Greco-Roman Mithraic culture was once considered to be the last pagan religion flourishing in the 100 years before Christ. But look closely and notice the ring of constellations in this bas-relief excavated from a Mithraic temple.
One of the interesting things over the last 30 years, I think, is in seeing the sacred space of the Mithraea, of the temples to Mithra, as containing a star map in one form or another. And so the way in which these devotees thought about themselves in relation to the universe, we now think much more heavily that the answers lay in the stars.
Although these cultures were highly advanced, they seemed to decline into a worldwide dark age. Ancient Egypt, the Greek and Roman empires, the megalithic and Mayan civilizations all collapsed and their knowledge was lost. To Plato and others, this fall of civilization was an inevitable part of the cyclical nature of the great year, unlike the linear model that modern historians suggest.
They postulate straight line type civilization, therefore using that as a paradigm. Everything that came earlier has to be can't be as refined as what we have now, and everything in the future is going to improve. But obviously, if we look at the facts, the records, we see that that is not true.
Virtually all civilizations all over the world, including so-called primitive societies, which have no connection with each other, have certain things in common. Practically all of them have deluge myths. Practically all of them talk about earlier times, golden ages, when people lived longer and were much more enlightened and advanced. And then they go downhill. To me, the only way to really understand that is to take seriously the Hindu or Vedic notion of the yugas. In other words, that there is a cycle corresponding to spring, summer, autumn, winter, and you might say that this prevails metaphysically or spiritually to the human race itself.
This cycle of the ages was given different names by different cultures. To the Greeks, it was the Great Year, broken down into 4 periods: the Iron, Bronze, Silver, and Golden Ages, each age having its own distinct characteristics. The saints and sages of ancient India called it the Yuga cycle. The Babylonians and Egyptians had still other names for it, and the Greco-Roman Mithraic culture identified it simply by its observed celestial movement, the precession of the equinox. One of the most obvious astronomical cycles is the occurrence of the spring and fall equinoxes, the 2 days of the year where day and night are exactly equal in length. Ancient calendars were set by these consistent markers, which are still used today to calibrate universal time. And ancient star watchers faithfully observed the celestial movements and patterns in the sky. A key observation was that certain constellations follow the same path in the sky as the sun. These 12 constellations make up the zodiac and were considered the most important. Twice each year, on the day of the equinox, when they made their observations, ancient astronomers realized that over time the constellations were not in the exact place in the sky that they had been the year before. The stars seemed to be moving backwards across the sky, a movement known as the precession of the equinox.
This is the phenomenon that we see, that the positions of these stars, when we look from Earth and look up to them at a certain time of the year, then they will not be in that same position in thousands of years to come, or they were at that position thousands of years ago.
The Mithraic culture, which flourished in ancient Greece and Rome, believed that their main god, Mithra, was responsible for creating precession.
One of the ways to try to describe or try to explain the bull killing scene is to see the bull as the constellation Taurus, and to see Mithras as Perseus, ending the age of Taurus, ending the remote period in which the constellation Taurus was dominant, somewhere between 4000 and 2000 BCE.
At the birth of Christ, the constellation Aries was becoming less dominant in the night sky at the time of the spring equinox, and the constellation Pisces was moving in to take its place. Pisces is the constellation associated with the Christian symbol of the fish. We are still in Pisces today. Very soon, the spring equinox will fall in Aquarius. This dawning of the age of Aquarius is a modern reference to the motion of the great year. As the equinox moves through the constellations of the zodiac, the North Pole points to different stars in the northern sky.
You look above the North Pole vertically and you will see the polar star. And 13,000 years from now, there will be not the polar star above you, but some star which is very far away from today's polar star, which will then have the role of the polar star. Which means if you take a photograph of a few hours at the night sky in the northern hemisphere, you see the stars as circles. And in the middle of these concentric circles, there is a fixed point. That's where now the polar star is, and again, in a few thousand years, this will be a completely different star, because the Earth axis will point to a different position in the sky.
To the ancients, this shifting of the polar star and the precession of the equinox through the constellations of the zodiac acted as a giant clock of the ages. Although today the ages are marked by the vernal equinox, the ancients used the autumnal equinox as the hour hand of the ages. Each constellation of the zodiac takes roughly 2,000 years to pass through the equinox, with a complete cycle taking around 24,000 years, the great year.
The cycle, as taught by the ancient Indian sages and also by Swami Sri Yukteswarji, who was just recent, is 24,000 years approximately, 24,000 year cycle, of which 12,000 years is ascending and 12,000 years is descending.
Ancient Indian and Greek cultures divided this great year into two halves, ascending and descending cycles of 12,000 years each. Each half was comprised of 4 parts. The Greeks called them the Iron, Bronze, Silver, and Golden Ages. The great sages of India called these ages yugas, and they were divided into the Kali, Dwapara, Treta, and Satya Yugas. The Iron Age, or Kali Yuga, was a dark time for civilization. The Golden Age, or Satya Yuga, was the age of enlightenment. An awareness of these changing ages can be seen in Mithraic temples and statues.
The bull slaying scene very often is framed by 2 figures, Cautis and Cautopates, young men holding a torch up and holding a torch down. And I think the most plausible explanation now on the table is that these represent day, night, growth, decay. And so we have a kind of inauguration, in a way, to the cosmic progression.
Over a period of time, man's ability to comprehend what is going on changes, and that in a certain part of that cycle he is only able to use a certain part of his brain, and then he uses more and more as time goes on. He's able to express things and understand nature and what is happening, and the whole process of creation is going on in a better way. Then, after a period of time, it goes down in a descending cycle, and that is gradually lost again.
It is often said that history repeats itself, but we are not used to looking at history over such a long period. The Great Year provides a method to track long periods of time and perhaps the rise and fall of civilization.
Kali Yuga is basically the age of materialism. The normal individual in that age has no conception of the existence of things that he cannot perceive or connect with through his senses and his mind. More subtle forces for the general person that age would be beyond their comprehension. They simply could not imagine such a thing.
The last Kali Yuga, or Iron Age, coincided with the worldwide Dark Age of the medieval era. Famed author and historian H.G. Wells described this time.
Our histories of these times are very imperfect. There were few places where men could write, and little encouragement to write at all. But we know enough to tell that this age was an age not merely of war and robbery, but of famine and pestilence. To many in those dark days it seemed that all learning, and all that made life seemly and desirable, was perishing.
As time progressed, the Kali Yuga came to a close, and the renaissance of the higher ages began with the Dwapara Yuga.
And if you'll notice, it doesn't take much looking at history to discover that that was exactly about the time when we began to get a grasp of these finer forces such as electricity and other things of that nature, and scientific process began to start to develop in a big way.
In 1600, William Gilbert discovered magnetic forces. In 1609, Galileo produced a telescope, and Kepler put to paper his laws of motion. These events, together with Newton's writings on gravitation and planetary motion in 1670, quickened the pace of scientific discovery and propelled the innovations of the Renaissance. Technological advancement is the hallmark of the Dwapara Yuga, which will last another 2,000 years.
The next age is called the Treta Yuga, or the age of mentality, where the mind begins to play a more and more powerful part. The next cycle is the spiritual age, and that is a fascinating age because in that time, according to the ancient scriptures and according to what our guru said, humanity as a whole will be able to comprehend and understand God.
The Treta and Satya Yugas, or the Silver and Golden Ages, may be incomprehensible to us, given our current state of development. Today, such accounts of yogis with Christ-like powers are called legends or folklore. But perhaps this lack of understanding merely reflects the fact that we are nearly 9,000 years beyond the end of the last golden age, when some say telepathy, levitation, and healing powers abounded, and we lived in perfect attunement with nature.
If you can go back and find out things are that way, then that would give some proof. The unfortunate part is, of course, most all of those old records have been destroyed. Now, they are beginning to find some of them. And one of the interesting facts is you go back to some of these golden age things that come down, and not only in India, but in some other cultures, Chaldean, for instance, and you find out they're talking about flying machines.
Considering the way man's intelligence has expanded, and its technology has advanced in just the last few hundred years, since the beginning of the Dwapara Yuga, mankind's capabilities might seem almost magical a few thousand years from now. Not everybody agrees on what determines the rise and fall of civilizations, but one thing is clear. The slow procession of the equinox through the constellations of the zodiac is an observed fact. Precession of the equinox and the changing of the polar star are complicated celestial movements that stargazers have studied and tried to explain for thousands of years. Megalithic structures like Stonehenge and pyramids throughout the world appear well suited for the observation of this fundamental celestial motion.
The star shafts of the Great Pyramid are carefully oriented to the positions in the sky of Sirius and the belt of Orion. Well, in order to do that and know that it's going to be there when the pyramid's built at 2500 BC, suggests that they're watching the stars very carefully because they're able to orient this narrow little shaft to those stars. So hard to imagine that they don't know it's moving, and it's moving because of precession. And then there's the famous zodiac of Dendera. The orientations within that zodiac demonstrate or are signaling earlier stages of Egyptian civilization. And yes, in Greek times, certainly precession was known, but why would they call attention to earlier stages within the precessional cycle in this much later temple if they didn't already know about precession?
While ancient structures suggest an earlier knowledge of precession, Western scholars generally credit the Greek astronomer Hipparchus with making the first systematic observations around 120 BC. Another Greek astronomer, Aristarchus, chronicled the movements of the Earth, Sun, and Moon. He proposed that the Earth revolves around the Sun almost 2,000 years before Copernicus did. Archimedes, the well-known mathematician and astronomer of the same era, taught the heliocentric theory of Aristarchus.
The fixed stars and the sun remain unmoved. The Earth revolves around the sun in the circumference of a circle, the sun lying in the middle of the orbit.
Modern science, of course, confirms that the sun is at the center of our solar system, but this knowledge was lost for almost 2 millennia, and the Earth was mistakenly thought to be at the center. This geocentric solar system was taught by Ptolemy and supported by the Roman Catholic Church for centuries. Ptolemy had to assume some wild movements of the planets to support his incorrect theory. He said they moved in epicycles. He could see the sun rose in the east and set in the west, and proved that the sun went around the Earth. What he did not realize was that another reference frame was at work. The Earth was spinning on its axis. Then, about 1,000 years after the pit of the Dark Ages, Polish astronomer Copernicus rediscovered what the Greeks had long forgotten, that the planets revolve around the sun.
The interesting point was, it was lost approximately 1,000 years before the depths of Kali Yuga and brought back about 1,000 years after, which then shows this idea that what is lost, then it comes around again. And so these cycles just go on and on, these 24,000-year cycles.
When he wrote his paper explaining the solar system, Copernicus observed 3 motions of the Earth. The first motion is the Earth's daily spin on its axis. The second motion is the Earth's annual trek around the sun. But he needed a third motion to explain precession. He used the term wobble or libration, assuming that only a wobbling Earth could cause us to see a different part of the constellations each year. Over 100 years later, Sir Isaac Newton applied his theories of gravity to the idea of a wobbling Earth. He determined that the sun and moon were the only things big enough and near enough to cause the wobble. This explanation of precession is known as the lunisolar theory. Another factor that might contribute to the wobble is the shape of the Earth.
If the Earth were a perfect sphere, there would be no precession, because there would be no way to apply that torque on the Earth. But since the Earth spins, it makes itself oblate by that spinning, so it has bulges on the equator. So this leads to a net force which would want to put the Earth upright. That's what the Earth doesn't allow it to do, but the Earth cannot completely escape that pull from the Moon, and instead of being positioned upright, it will shift the orientation of the axis. In other words, it will cause this precession.
This is the predominant theory among astronomers today. But in 1749, French astronomer Jean Léron d'Alembert found that Newton's lunisolar equations did not quite work, so he added variables for torque and inertia. Still today, lunisolar precession formulas continue to be adjusted, and some say they don't reflect physical reality.
According to the theory of lunisolar precession, if the axis of the Earth were to change relative to the Sun, this would have an effect on the seasons on the Earth. They would occur earlier or later, so we would notice variations, but this does not happen.
The seasons are caused by the tilted Earth revolving around the Sun. Any change in the tilt of the Earth, whether due to a massive meteor impact or the subtle wobble of lunisolar theory, would result in a change of seasons, even though our calendar would stay the same. Lunisolar precession theorists reconcile the regularity of our seasons by requiring the equinox to occur before the Earth completes its full 360-degree orbit around the Sun. But this solution contradicts lunar equations and observed eclipse cycles. Each answer merely creates a new question. Could there be an easier explanation of precession? Ancient scholars who observed precession of the equinox provided a simpler explanation than a wobbling Earth. They said that our Sun curves through space, moving in a great orbit of its own, pulling the Earth and other planets along with it. If the Earth did move along with the Sun on a curved path through space, we might see the same precession of the equinox through the zodiac and changing of the pole stars that the lunisolar wobble theory now attempts to explain. But it would not be caused by the Earth's wobbling independent of the Sun. It would be caused by the whole solar system curving through space. Another reference frame is at work.
We believe that our Sun moves in space with our entire solar system, that the axis of our Earth remains aligned to a point in space where that is fixed in respect to the equinoxes, it's fixed in respect to all the solstices, so that basically our entire system moves around a point in space. And this point in space, we believe, is a star.
A partner star to our own Sun? Some say the binary model confirms all of our celestial observations without the need for excessive torque or epicycle-type explanations. While the concept of a second Sun challenges our present understanding of the solar system, it is hardly a new idea. Some of the earliest astronomical records refer to the existence of dual suns. In fact, Mithraic beliefs were based on this concept.
There's one sun which is part of the planetary system, and there's one sun outside the solar system. And this allows Mithras to both be the sun, Mithras sol invictus, Mithras the unconquerable sun, and also seem to be operating for the sun or on behalf of the sun.
The yogis of ancient India accepted the binary model as a matter of fact, and also mentioned that it was the cause of precession. In 1894, Swami Sri Yukteswar, a great Hindu sage, described our solar system and the great cycle.
We learn from Oriental astronomy that moons revolve around the planets, and planets turning on their axis revolve with their moons around the sun. And the sun, with its planets and their moons, takes some star for its jewel and revolves around it in about 24,000 years of our Earth, a celestial phenomenon which causes the backward movement of the equinoctial points around the zodiac.
The theory, the binary, is that our sun is rotating around another sun. And that, of course, the system, what you might say, is also rotating around what they call the grand central sun.
Could it be that the ancient knowledge of this dual sun was lost during our descent into the dark ages of the Kali Yuga, just as we lost our knowledge of a heliocentric system? And as we now ascend toward the golden age once more, will science rediscover this binary companion? As we look deeper into the universe and expand our knowledge of its motion, we've come to realize that single suns are more the exception than the rule.
Roughly half of the stars you find in the universe are alone, and the other half are in groups, and often the groups consist of two, and if that is a group of two, then we talk about binary stars. But it can also be 3, 4, 5, there's no limit on that.
Binaries, it seems to be the common observation in the cosmos now. Most of them are actually binary systems.
With so many binaries in the heavens, why wouldn't our sun have a partner? Then again, if it did, wouldn't we be able to see it by now with our high-tech observatories or the Hubble Space Telescope? While there might not be a visible companion, it doesn't mean one's not there. Some stars can't be seen at all, such as black holes or old neutron stars, and others, like brown dwarfs, are barely detectable. Also, the long orbit period of 24,000 years will make the connection of our sun to a binary partner extremely difficult to detect. One sign we'd expect to see would be the changes in the sun's rate of movement. In a binary system, orbital speed is not constant, and theorists say it would cause changes in the precession rate.
As soon as two celestial bodies orbit each other, according to Kepler's laws, you have elliptical orbits. And if you have that, you have where when the bodies are closer to each other, they tend to be faster, and then as the other object moves further away, it gets slower and in again.
If the current rate of speed were constant, a complete binary cycle would take almost 26,000 years. But scientists have confirmed that the rate of precession is increasing. In a binary system, this would mean that two stars are moving closer together, and the cycle would take much less than 26,000 years.
Analysis of the data has shown that it is actually closer to a 24,000 year period. If we keep observing, if we make future measurements, that would indicate certainly that we are in a binary system.
The cycle of a binary system might also be observed in the geological record. Mathematician Milutin Milankovitch noticed the Earth has had global warming and cooling cycles that roughly correlate to the length of the Great Year. Just as the binary model answers questions of the past, it could also be applied to solve scientific questions of the present. For example, at the edge of our solar system is a field of asteroids known as the Kuiper Belt. In 2001, a team of scientists from the University of Michigan made a startling discovery. The asteroids appear to end very abruptly. A sheer edge like this would be expected in a binary system. Also, a large number of long-cycle comets in our solar system come from a very small part of the sky. Although some astronomers like John Matisse and Daniel Whitmire think it may result from the gravitational pull of an unconfirmed 10th planet, our sun's binary could also have this effect. Another enigma. All celestial bodies have angular momentum, a force that corresponds to their mass and motion. Yet in our solar system, angular momentum is unevenly distributed. The Sun has 99.9% of the total mass, but only 1% of the total angular momentum. If we acknowledge that our Sun is curving through space in a 24,000-year binary orbit, we find the Sun's angular momentum was there all the time, but primarily in its orbital motion, not just in its spin. Although the possibility of a binary star agrees with many observed facts, it does raise questions. Where is it? How do we find it? The most common objection is, if we were in a binary system, we would know it by now. But we may be looking for something that is very far away and very hard to see.
One of the stars might have evolved enough so that it has died and has become a white dwarf and then lost a lot of its heat and became faint as well. Or it might have been a wannabe star who just was born as a brown dwarf and never became a real star and is too dark for this. But if it's sufficiently far away and sufficiently faint, then it would just sit there and maybe orbit the Sun within a few thousand years. Who knows? I cannot have any positive opinion about this, but I would not rule it out.
Perhaps we've already seen our Sun's binary companion, but clinging to old theories kept us from realizing it. If so, it would not be the first time that new knowledge was met with resistance. An Earth-centered solar system was undeniable fact until Copernicus realized that another reference frame was at work. The Earth itself was moving. And Einstein denied the existence of black holes, even though his theories predicted them.
People also believed in the flat Earth, and it kept for long periods of time. It's just a thought that is embedded, so deeply embedded, that we just don't see the other world. That we don't see an alternative. That we might see a phenomena, but we don't see the reality of it.
It may be that still another reference frame is at work. The solar system could be curving, producing the change in orientation we call precession, and just maybe ushering us into a higher age. And so we continue our quest for the truth, using new technologies to see much fainter and more distant objects in space. Astronomers at the University of Hawaii have now detected a very faint brown dwarf companion to a nearby star. And recently, scientists detected a Kuiper Belt object more than half the diameter of Pluto. It is likely we're just at the beginning of a string of such discoveries.
If it can be proven that our Sun is indeed in a binary system, that would certainly shed some new light on the knowledge and wisdom that ancient civilization had.
They understand the rules and the laws by which we human beings are here on Earth, and they understand that we're here for a particular purpose. We're not accidental glitches in a meaningless universe.
I think the proof will come. We just haven't got to the point where we're able to figure it out yet.
New discoveries in astronomy and archaeology are adding more and more to our understanding of the true depth of our own history. If we continue these pursuits, perhaps we will prove the link between binary motion, precession, and man's place in the great year.
There's going to be changes that are coming that are going to be mind-boggling to humanity.
History reveals that ancient cultures around the globe were aware of a great cycle that connected the movements of the heavens and life on Earth. The great year tracked not only time, but perhaps we will find the very rise and fall of civilization itself.
To everything turn, turn, turn. There is a season, turn, turn, turn. And make time to every purpose under heaven. A time to be born, a time